Hi everyone, so today we are going to have a revision on functions. I have prepared a revision paper that you can download from the description. Alright, so let's proceed to question number 1. So let's say, for example, you are going to sketch the graph of y is equal to 5x minus 7 by showing the coordinates of the points where the graph meets the coordinate axis. So as I have mentioned last time, we need to find your turning points first. So how to find the turning points? That will be 5x minus 7 is equal to 0. So therefore, 5x is 7, and that will give us an x which is 7 all over 5. So therefore, your turning point is at 7 over 5, and of course, the y value is actually 0. So this 7 over 5 over and 0 is also your x-intercept. Okay, the next thing that we need to find is your y-intercept. So that means we let x is equal to 0. So y is equal to the modulus of 5 times 0 minus 7. So in the end, our y is modulus of negative 7, and that will give us positive 7. So therefore, our y-intercept is 0, 7. So this is y-intercept. Now, if we're going to sketch the graph of your function, of course, this is not drawn to scale. So let's say, for example, my 7 over 5 is half of 7. So I would say, let's say, this is 7 over 5, right? And this 7 over 5, 0 is the x-intercept. And 0, 7, so let's say 7 is here, is the y-intercept. Remember, as I mentioned, you will have a line of symmetry, so you only have to look at the difference between the one point to the other. So that will give us, this is 7 over 5, so you have to do the same thing here to identify the other point. So that means this point is 14 all over 5. So therefore, when x is 14 over 5, the value of your y is also 7. Alright, so by connecting all of your points, then you will have this graph. So this is the graph of your function y is equal to the modulus of 5x minus 7. Alright, so in part B, we need to find the values of x that would satisfy this equation. So remember that in finding the values of x here, remember that we need to isolate your expression that is contained in the modulus first. So this will give us 15 once we transfer your positive 1. So it will give us 5x minus 7 is equal to positive 3 by dividing both sides by 5. So therefore, remember we have two possible cases. So we have case 1. In that case 1 is 5x minus 7 is 3. Right? And your case 2 is that 5x minus 7 is equal to negative 3. Right? So then we solve for x here, so that will give us 5x equals 10, and so therefore x equals 2. Oh, sorry, x equals 2. And the other one is 5x is equal to, transfer minus 7 to the right, that will give us positive 4. And then the value of x is 4 over 5. So these are the solutions to your equation. Okay, in question number 2, we are given with a function g defined by this for x greater than negative 3. So what we're looking for is the g inverse of x. So the first thing that we need to do is rewrite our g of x as x plus 3 square minus 7. Then the next thing is we change this to y is equal to x plus 3 square minus 7. Then we interchange x and y, so that will be x is equal to y plus 3 square minus 7. Then we make y as the subject of the formula. So x plus 7 is y plus 3 square. We solve for y, we take the square root of both sides. So x plus 7 is equal to y plus 3. So therefore y is equal to square root of x plus 7 minus 3. Therefore, our g inverse of x is equal to the square root of x plus 7 minus 3. Okay, so in part B, we are solving the equation g inverse of x is equal to g of 0. Remember earlier, our g inverse of x is already x plus 7 minus 3, and our g, function g, is given by x plus 3 square minus 7, right? But in this case, we are looking for g of 0 at the right side. So we're going to replace x by 0. So what will happen? We will have x plus 7 minus 3 is equal to, this will give you 9 minus 7, that will give us a 2. So therefore, finding x algebraically, we have to manipulate the equation. This will give us a 5, removing the square roots by taking the square of your equation, and that will give us x plus 7 is 25. So therefore, x is equal to 18. Question 3, we are given with your function f of x is equal to ln of 5x minus 10 for x greater than 0. Okay, so remember in your Math 0580 that if you're going to graph a ln function, it will look like this, right? So it has an asymptote, a vertical asymptote, in which the function inside is equal to 0. So therefore, in this case, this is x is equal to 2. So your ln function is asymptotic to your line x equals 2. But as you can see, the y values can be negative as your graph goes to negative infinity, and it also approaches positive infinity as your x values increases. So therefore, the range of your f of x for this item is, the range of f is all real numbers. So that means equal to negative infinity to positive infinity. So that is the range of your function f of x. Okay? Sometimes in IGCSE, we just write it as real numbers. So that means it can be any real number. Second part, we need to find the f inverse of x. So f inverse, remember you are given with the function f of x already. So we're going to replace this by y is equal to ln of 5x minus 10. And then interchange x and y. Then solve for y. We'll make y as the subject of the formula. So to get rid of n, we raise this to e. So e power of x is equal to e power ln of 5y minus 10. And this will give us e power of x is equal to e to the power of ln will be 5y minus 10 only. So therefore, e power of x plus 10 is 5y. And then, to solve for y, we divide everything by 5. So that's e power of x plus 10 all over 5. Therefore, your f of x, or f inverse of x, is equal to e to the power of x plus 10 divided by 5. Okay? Part 3, you need to state the range of your f inverse. Now remember that based on the previous video about the range and the domain of your inverse function, the range of the f inverse is actually the domain of f. Now, going back to the given item, the domain of f is for all x greater than 2. So therefore, that domain becomes the range of your function f of x. So I'm just going to write it here. So range of f inverse is values of y greater than 2. Part 4. Solve for f of x is equal to 0. So therefore, we are solving f of x is equal to 0. Our f of x is given by ln of 5x minus 10 is equal to 0. Right? So when will this happen? So we take, when we have a ln, we put this as e. So e to the power of ln of 5x minus 10 is equal to e to the power of 0. So this will become e to the power of ln will just give you the expression inside the ln. And any number raised to 0 will always be 1. So that will give us 5x is equal to 11. So therefore, x is equal to 11 over 5. Alright. Now, in part 5, sorry, I have to move the whole thing. In part 5, we are given with another function g of x, right? And that g of x is equal to 2x minus ln 2, right? So what we are looking for is we need to solve gf. Okay, let me write it here again. So this is, we need to rewrite gf of x is equal to f of x squared. Okay, yes, I copied it correctly. So now how are we going to solve this item? Let me put it here. Okay, so take note that when we are looking for g of f of x, that means we are putting f inside of g. So in the end, we are going to have 2. The value of x will be replaced by function f, and your function f is given by ln of, what was that again? Ln of 5x minus 10. Okay, so 5x minus 10, right? Minus ln 2, correct? So now this is your g of f of x is equal to f of x squared. So that means the input is now being replaced by x squared. So that will give us ln of 5. Instead of x, we're going to replace this by x squared minus 10. Understand? So simplify the whole expression. This will give us 2 ln of 5x minus 10 minus ln 2 is equal to ln of 5x squared minus 10. So in the end, this will give us the 2 will go to the power. So this is ln of 5x minus 10 squared minus ln 2 is equal to ln of 5x squared minus 10. I haven't discussed this yet, but I'm gonna discuss further about the properties of logarithmic functions in my succeeding videos. So for now, I'll be using all those properties of log to solve this item. So since this is minus, this actually means division, okay? So that will give us ln of 5x minus 10 squared all over 2 is equal to the ln of 5x squared minus 10. However, since we're saying that ln of something is equal to another ln of something, this will be equal if these expressions inside are just the same. So meaning we can simplify it further as 5x minus 10 squared all over 2 is equal to 5x squared minus 10. So in the end, this will give us 25x squared minus 100x plus 100. I'm going to transfer 2 to the right side, so that will give us 10x squared minus 20. So in the end, transfer everything on the left side, so that will give us 15x squared minus 100x plus 120 is equal to 0, right? And I think everything is divisible by 5. So in the end, this will give us 3x squared minus 20x plus 40. Oh, no. Divide by 5 is 24 equal to 0. And then let us see if this is factorable. Then we can finally solve for your x value. However, this isn't factorable, so using your quadratic formula, we can get a value of x which is equal to 1.57, and the other one is 5.10 approximately. All right. Okay, in question number 4, we are given with this quadratic function and we need to write it in this form. So how do we do that? Remember in the previous video, what we're going to do is to complete the square. So in order for us to complete the square, we need to factorize 2 first. So that will give us 2 bracket x squared minus 6x plus 5. And remember, the value that we're going to add or subtract to your function is the b over 2 square. So in this case, this is negative 6 over 2 square. So that will give us negative 3 square. So in the end, it's a positive 9. So that's what we are going to add. So that will give us x squared minus 6x plus 9. So whatever we added, we must also subtract to balance the whole equation, right? And take note that the first 3 terms can be written as a square of a factor. So that will become x minus 3 squared minus 4. So finally, our answer will be 2 bracket x minus 3 squared. Distribute the 2, so that will give us minus 8. Okay? Now in question 2, we are tasked to graph your function of the modulus. In other words, this one is modulus of 2x squared minus 12x plus 10, because that's our given function earlier. Now remember as well, in the previous video, I mentioned that if you're graphing a modulus function where f of x is a square, is a quadratic function, you need to graph your quadratic function first, right? But in order for us to graph that, we need to find the turning point and the intercept. So we first find the turning point. But in this case, we already changed your quadratic function into this form, right? So that means our turning point is at 3, negative 8, correct? And then the next thing is we find your y-intercept by letting x is equal to 0. So that will give us y is equal to 2 times 0 squared minus 12 times 0 plus 10. So in the end, it gives us a y is equal to 10. So therefore, our y-intercept is 0, 10. Right? And then for the x-intercept, of course, we let your y equal to 0. So that means 2x squared minus 12x plus 10 is 0. Divide everything by 2. So that will become x squared minus 6x plus 5. Find the factors. This will be x minus 1, x minus 5 equals 0. So therefore your x-intercepts are at 1 and at x is equal to 5. Now we have to complete information. Then we can graph your quadratic function. And then later on, we can use the graph of your quadratic to estimate the graph of your modulus function. So we have, let's say x equals 1 is here, 3 will be here, and then we have a 5 somewhere here, right? And then when x equals 0, y is equal to 10. We just put it like that. And then when x is equal to 3, y is equal to negative 8. So we have this information. This is the first point, second point, third point, and the y-intercept. So this is a quadratic function, so it must be a U-shape, distributed curve. Okay, so connect the points. Sorry, my graph is not drawn to scale. You will have this. Okay, now let me change the color for the modulus. So now remember that when we take the modulus, our x-axis becomes a mirror line for the values of y below x-axis. So that means this one from 1 to 5 will be reflected upwards. So since that's a positive 8, so negative 8, so that will become positive 8. So this will be reflected above, that will become 3 positive 8. So the final graph of your function is the one in blue. So it's, remember, it's the W shape. So this is the final graph for your modulus function. Right? Last one, find the set of values of k for which the modulus equal to k has 4 distinct values. Now remember, f modulus of f of x is already the blue graph, right? And what we're going to do is we're going to graph your y is equal to k. Now, if k is any constant, that means this graph is a horizontal line, right? So you need to find the values of k for which it will have 4 distinct roots. That means when you draw a horizontal line, you will have 4 intersections, correct? So for example, here, this is a possible solution for k because you have 1 intersection, 2 intersection, 3, and then 4. So it has 4 distinct roots. So when the question that you need to ask yourself is when will it be not equal to 4? So that means it will be here, right? K, the value of k here is 0, isn't it? Because this is the function y is equal to 0. So therefore, it cannot be 0, but it can be more than 0. And where is the maximum? Notice that when y is equal to 8, you will only have 3 intersections. So therefore, the solution for your k will be greater than 0, but less than 8. So it can be anything from 0 to positive 8.